Hello, today we're going to look at some word problems that involve ratios, proportions, and percents. We're going to start off with percents, and specifically what you'll be doing is finding the percentage of a full amount. So let's use this first problem as an example. There are 50 seats on a train. 15 of the seats are empty. What percentage of the seats on the train are empty? So first of all, our final answer will be written as some sort of percent. The way we are going to start this is set up a fraction with the total number of seats on the train and how many are empty. So since there are 50 seats total on the train, 50 is going to be the bottom number of our fraction. That's the totals always go on the bottom. And the portion of them that are empty goes on top. 15 are empty. So this would be the representation of how many empty seats there are as a fraction. However, we want it as a percent. To switch a fraction into percent, first we change that fraction into a decimal. The way we do that is we do 15 divided by 50, which gives us the decimal. And then to convert the decimal to a percent, you can either think multiply by 100 or move the decimal 2 places to the left. Decimal is now here, so I need to fill in a 0 in that empty spot. So 15 out of 50 is the same as 30%. So 30% of the seats are empty. Same idea with the next one. Lauren ordered a set of beads. She received 300 beads in all. So 300 is going to be the bottom number of our fraction. 237 of the beads were blue. What percentage of the beads were blue? So we had 300 total beads. 237 of them were blue. So our fraction looks like 237 over 300. To switch that into a decimal, oops, if I type the right things in, we type the fraction into Desmos. And that Desmos tells us that's the same as 0.79. Then we switch 0.79 to a percent by moving the decimal 2 places to the right. And so 0.79 is the same as 79%. So 79% of the beads were blue. 19 out of the 76 employees at the sports shop are part-time employees. What percentage of the employees at the sports shop work part-time? So total number of employees is 76. 19 of them are part-time, so that goes up on top. 19 divided by 76 gives us 0.25. And then move that decimal 2 places to the right. So we get that the number or percentage of employees that are part-time, 25%. Last of these style of problems. At Leslie's Swimwear, 1 out of the 5 styles at the store is bikinis. So 1 out of 5 is the same as the fraction 1 over 5 or 1/5. What percentage of swimsuit styles at the store are bikinis? So in Desmos, 1 divided by 5 is 0.2. And then let's move that decimal point 2 places to the right. Insert 0 in that empty space. 0.2 is the same as 20%. So 20% of the swimsuits are bikinis. The next thing we're going to look at are ratios. 2 ratios are equivalent if they reduce to the same fraction. So ratios can be written a few different ways. They can be written as a fraction. They can be written with the word 2 as in TO, or they can be written with a colon here, ... All of those mean the same idea. So the way we can tell if 2 ratios are equivalent is they reduce to the same fraction. And so if you're good at reducing fractions by hand, that works really well. Another way to do this with a calculator is to see if the 2 fractions have the same decimal form. If 2 fractions have the same decimal form, they also reduce to the same fraction. So there's 4 examples here with ratios. Each of these 4 examples, we're looking at 2 ratios that are either written with the TO version or the colon version. We're going to switch the ratios into fractions and see if they reduce to the same amount. So looking at this one right here, 6 to 9 is the same as the fraction 6 divided by 9. 10 to 15 is the same as the fraction 10 over 15. I'm going to delete this stuff here. You can try to reduce these by hand, or a little faster, maybe easier, would be to do things in Desmos. We get that 6 over 9 is the same as 0.6 repeating essentially. 10 divided by 15, we get the same decimal form. So these are, yes, they are equivalent. Let's try another one. We have 8 to 16, so 8 on top, 16 on bottom. We have 5 to 19. So 8 over 16 is the same as 0.5. 5 over 19, we get a completely different decimal. Since those are not the same decimal in form, when you change them to decimals, those are not equivalent. And delete these to get them out of our way. For the next one, we have 12 cents over 15 minutes, and we have 4 cents over 5 minutes. Let's type those two fractions into Desmos. 0.8 for the first one and 0.8 for the second one. Since we got the same decimal amount, yes, those are equivalent ratios. Last one, we have 8 items to 3 years, so 8 over 3, and 16 items to 6 years. Let's see if we get the same decimal for those. And we do, so that one is a yes. I'm not going to show you all the yeses, but let's just use that last one as an example. I can't reduce the fraction 8 over 3 any further because there's no number I can divide both 8 and 3 by other than 1. Notice that 16 over 6, I can divide both of those numbers by 2. 16 divided by 2 is 8. 6 divided by 2 is 3. So those two are the same fraction when you reduce the second one. That's the other way you can think about these. The last one's just a few more proportions word problems. We've done these in a previous lesson. Remember, for a proportion, we have basically two fractions that are set equal to each other. You need to have 3 out of the 4 parts of the fractions filled in with a number, and then one amount that you don't know. We'll usually just call that x. It doesn't really matter where this x is as long as the other 3 spots in those 2 fractions have a number in them. Let's go ahead and take a look at one just in context. Ariana picked 21 cups of ripe strawberries from her garden. She plans to use all of the strawberries to make strawberry jam. Her recipe calls for 2 cups of sugar for every 7 cups of strawberries. So we have sugar over strawberries. That sentence right here says we need 2 cups of sugar for every 7 cups of strawberries. So we're thinking 2 over 7. How much sugar does Ariana need to use? Looking back at the first sentence, she has 21 cups of strawberries. Strawberries go in the bottom of the fraction, so 21 goes here. Sugar is what we are trying to find. Sugar is the top part of the fraction, so that's going to be an x. Just like we did with previous problems, to solve these, we cross multiply. So we think 2 times 21, multiplying on the diagonal there. I don't know what I just wrote there. So 2 times 21 equals 7 times x, or 7x. 2 times 21 is 42. And then to get x completely by itself, divide both sides by 7. And we get x equals 6. And specifically, they're asking how much sugar, so 6 cups of sugar. Next one. On rainy days, Francesca likes to ride the stationary bike at the gym. Yesterday, she rode for 30 minutes and covered 6 miles. So we're thinking minutes to miles based on this sentence right here. So one of our fractions is going to be 30 minutes on top, 6 miles on the bottom. Today, she plans to ride 8 miles. We know miles go in the bottom of the fraction, so 8 is going to go in the bottom of the other fraction. If she rides at the same rate, how many minutes, since we don't know how many minutes, that's x minutes go in the top of the fraction, so x goes in the top, will it take Francesca to ride today? So now we cross multiply. Actually, I'm going to delete this stuff over here. Multiplying on the diagonal, 30 times 8 is 240. 6 times x is 6x. To get x by itself, we divide both sides by the number in front of it, which is 6. And we get x equals 40 minutes. Xavier loves to make waffles for breakfast. Normally it takes him 9 minutes to make 3 waffles. So our ratios here is going to be minutes over waffles, 9 minutes to make 3 waffles. He had some friends sleep over last night and he wants to make 10 waffles this morning. 10 is the number of waffles. Waffles go on the bottom. If the waffles cook at the same rate, how many minutes, since we don't know how many it's x, minutes go in the top of the fraction will it take him to make the waffles this morning? Now we just solve this proportion by cross multiplying. 9 times 10 is 90. 3 times x is 3x. And then divide both sides by the number in front of x to solve. 90 divided by, oops, I typed in the wrong. 90 divided by 3 is 30. So we get x equals 30 minutes. Last but not least, last week, Laura volunteered at the community cleanup event and earned 2 patches for her Scout uniform. She spent 4 minutes sewing the patches onto her uniform. This week, Laura spent the week at the Scout camp and earned another 6 patches. So instead of having things in the same sentence, it kind of broke things up. She earned 2 patches, and it took her 4 minutes to sew them on. So patches over minutes is our fractions. 2 patches took 4 minutes of sewing. Looking at the next sentence, this week Laura spent the week at Scout Camp and earned another 6 patches. 6 patches go on the top. How many minutes is what the question is asking us for? Since we don't know the number of minutes, it's x. Minutes go on the bottom of the fraction. Now let's solve our proportion. So we cross multiply. 2 times x is 2x. 6 times 4 is 24. And then we divide both sides by the number in front of x. 24 divided by 2 is 12. It's asking how many minutes, so 12 minutes for our final answer here. So nice little recap of many of the concepts we've talked about so far. That is it today. Have a fantastic day.